back. Problem 15. Make a substitution to express the integrand as a rational function, then evaluate the integral. So this is definite integral 0 to 1 negative 10 over 1 plus cube root of x dx. So let's see. Let's take u equals cube root of x. What does that mean? U to the power 3 is x. It should be x there. Which tells us 3u squared du is dx. So dx is 3u squared du. When x is 0, u is 0. When x is 1, u is 1. So integral 0 to 1 negative 10 over 1 plus cube root x dx is integral 0 to 1 negative 10 dx is 3u squared du 1 plus u. Okay. So notice negative 10 times 3 negative 30. U squared over 1 plus u. Use long division to divide u squared by 1 plus u. You get u minus 1 plus 1 over u plus 1. Okay. When in doubt, check. Let's check. You are going to divide u squared by u plus 1. 1 plus u is nothing but u plus 1. So let's write u squared here and u plus 1 here. You see, because this is degree 2, you need linear term which is 0u and a constant term which is simply 0. So look at leading term and leading term. U times u is u squared. Once you have this, you need to multiply u times 1 to be plus 1u. So that is simply u. Subtract, subtract. You get these two cancel. You are left with negative 1u. And simply 0 as the constant term. All right. Now, u goes in negative 1u, negative 1 times. So, negative 1u, negative 1. So, remember, we always subtract the second line from the first. That is, we change signs, which tells you this cancels. This gives me positive 1, which is your remainder. In other words, quotient is u minus 1. Remainder is 1. Okay, so remainder is not 0. So I'm still basically dividing. That's why 1 over u plus 1. All right. So when you integrate this, this is simply polynomial. Integral is u squared over 2 minus 1. Integral is negative u. Integral of this is natural log u plus 1. Don't forget limits of integration 0 to 1. 1 gives me half minus 1, that's negative half, and natural log 2. 0 gives me 0 here, 0 here, natural log of 0 plus 1. Natural log of 1 is 0. So this limit gives me 0. This limit gives me all of this. Negative 30 times negative half plus natural log 2. Negative 30 times negative half plus natural log 2. Okay? Because this is definite integral, there is no more constant of integration. Good. Next problem. Integral negative 4 cosine x over sine squared x plus sine x. This is straightforward. You substitute u equals sine x. Then du equals cosine x dx. So integral negative 4 cosine x over sine squared x plus sine x dx is cosine x dx is du. So all I have is negative 4 du upstairs, and this is u squared plus u downstairs. This factors. u times u plus 1. Negative 4 has been pulled out. That's it. These are linear factors, non-repeating. So I have a constant for u and I have a constant for u plus 1. Those are the partial fractions. When I simplify all of this, I get a equals 1, b equals negative 1. Okay, the same procedure. So what happens? I have a negative 4 here. I have written it outside. That's my integrand, which I just resolved to be 1 over u minus 1 over u plus 1. When I take the integral natural log u, absolute value u minus natural log absolute value u plus 1. But don't forget, question was in terms of x, so answer should be replacing u by sin x. That's it. All right. So let's try. Don't forget constant of integration. So let's try. Negative 4 parenthesis natural log absolute value sin of x absolute value minus natural log absolute value sin of x plus 1 absolute value close parenthesis plus constant of integration. Okay, very good. Next problem. Integral negative 2 natural log x squared minus x plus 2 dx. This is a tricky one. Let's take some time to understand this. X squared minus x plus 2, you need to complete it as a square. So minus x plus 2, I need a 1/4. To get to 2, I need 7/4. Okay. So make sure you complete this as a square. Okay. Negative x tells me I have negative 1. I have to divide by 2 that coefficient and square it. That's how I get 1/4. Well, if I get take away 1/4 from 2, I'm left with 7/4 to make sure I have the entirety of 2 here. The first 3 terms is a complete square. So at this point, let me call x minus half to be u. So du is same as dx because this is simply a constant. So what happens here? This integral is negative 2 integral natural log u squared plus 7/4 du. Okay. So this integral, mind you, we are now going to use integration by parts. Keep the negative 2 outside. Integral of 1 times natural log u squared plus 7/4. I get u times natural log u squared plus 7/4 minus 2 times all of this. Okay. When you simplify this, you see you are again doing long division, or this is straightforward, u squared plus 7/4 minus 7/4. So that's a 1 minus 7/4, all of this. So integral of 1 is u. So that's where I have the 4u. Now minus integral of 7/4, 1 over u squared plus, so that 4 cancels the 4, so that quarter is gone. This quantity is nothing but tan inverse, integral of this quantity. So notice we are using many things here. One is a substitution. After substitution, because it's natural log of something, use integration by parts. And over here, you are basically reducing. This is a rational function. You're reducing, okay? Either long division, or you can simply detect what's going on. All right, u squared plus 7/4 minus 7/4. That's the numerator. And that gets me 1 here, okay? Either do long division or eyeball it. At the end, this feature gives me tan inverse or arctan. After going through all this, don't forget what is u, okay? U is x minus half, okay? So that gets me this entire solution here. It's a long expression, so let me write this down carefully. Hopefully I haven't made any error. X minus 1 over 2, whoops, natural log absolute parenthesis x squared minus x plus 2 close parenthesis plus 4x minus 2 square root 7 tan inverse is arctan of 2x minus 1 over 7. Lastly, a constant of integration. Whoops, did I make a mistake somewhere? Negative 2x minus 2 natural log x squared minus 4x minus 2 square root arctan 2x minus, oh, that should be a square root 7. So there you go. Now I hope it works. That's correct. Okay. Let's continue next problem in the next video.